Hello and welcome to another NGen Math 8 lesson by eMathInstruction. My name is Kirk Weiler and today we're going to be doing Unit 3, Lesson 5 on rotations. So a rotation is one of the very fundamental types of transformations that we can do, all right? In terms of so far we've seen reflections, right? That's our primary one. And then we've played around with a few other transformations sort of given by algebraic rules, but that's way back in like Lesson 1, okay? Today what we're going to do is we're going to concentrate on what a rotation really is, right? And you're going to need like a straight edge for this lesson, you're going to need a compass to draw like circles, and you're going to need a protractor in order to measure angles. And let's talk about why that is right away by talking about what rotations are. So, when you rotate a point, so forget about rotating a figure, because rotating a figure is just means rotating all the points that make up the figure. So when we rotate a point, what we need to do is we need to know the center of rotation, we need to know the angle of rotation, and we need to know the direction of rotation. And by that I mean, are we rotating clockwise or counterclockwise? It's basically that easy, right? So exercise number 1, let's take a look. Rotate point A counterclockwise about point C by an angle of 60 degrees. All right, so this exercise literally just walks you through what it means to rotate one point around another one. So letter A starts us off. Draw an arc of a circle that has its center at C and that passes through A in a counterclockwise direction. All right, so let's do it. So one thing that is true about a rotation is that you're taking the point that you're rotating, which is in this place A, all right, and you're keeping it the same distance away from some center point, C. Now to keep it the same distance from that point, what we need to do is we need to draw a circle that has this as its center and that passes through point A. All right, so here we go. This should be a little bit easier for you than me. Take your compass out, place the pointy end down on point C, and extend your compass far enough so that the lead portion now touches A. All right, we can now draw what's known as an arc. We could draw the whole circle if we wanted to, but I'm just going to kind of draw this arc. Now, I'm going to actually get rid of my compass. I don't need it anymore. Somewhere along this arc, our image point is going to be. Okay, all the points along this arc, right, which would be the full circle if we drew it, are the same distance away from C that A was. All right, and we're going in a counterclockwise direction, right, the opposite of the way that the hands on a clock would move. Now what we want to do is we want to figure out just a 60-degree rotation. So the next step, let me move this out of the way, letter B, draw ray CA. All right, so that's easy enough. This is literally just, let's take our ruler out, let's draw a nice ray that goes from C through point A like that. Now, the only reason we did that is to then be able to use our protractor. So, letter C says, using ray CA and a protractor, draw ray CA prime and plot point A prime. Now remember, right, what we're trying to do is we're trying to rotate this by 60 degrees, okay? So what we're going to do is we're going to take our protractor out, all right, and we're just going to create a 60-degree angle. That's it. Let me expand this a little bit, right? And in fact, I'm going to expand it to just right about there. Okay, so here, right up to here is 60 degrees. So what I want is I kind of want to just mark that location, kind of like, all right, that's right here. All right, that's my 60-degree rotation. So now, this is something you probably can't do, but I'm going to kind of collapse that a little bit, bring out my ruler, make sure I rotate it the proper amount, right? Bring it back down, get rid of that, still get rid of that, bounce this around a bit. Keep in mind, this is now a 60-degree angle, So this point right here is point A prime. And that's it. That's a rotation. It's a little bit of a pain to do by hand. I'm not going to lie to you, right? And like all lesson long, I'm going to be struggling with it because I've got these great electronic versions of what you've got on your paper. But it's that simple, right? Every time we want to rotate a point or an entire figure, we need to know the center about which we're rotating it. We need to know the angle that we're rotating it. And we need to know whether or not we're going counterclockwise, as we did in this case, or whether we're going clockwise. All right? And then we just need to use the proper tools to figure it out. Again, the key being, though, that when you rotate a point around another point, you're really just rotating it along a circle. You're making it travel along a circle, right, that has that as its center and that passes through the pre-image point. All right? Now, the last little piece of this problem, letter A, sorry, not letter A, but letter D, says verify that A and A prime are the same distance from the center point C. How far in inches are both points away from C? Well, number one, they've got to be the same distance away from C because they're literally both radii of this circle that I just drew, right? But I do want to verify it, so if I simply take my ruler out and I check, for me, point A is whoops, that's not what I want. Let me just get rid of this ruler now. Letter A is 2.5 inches away from C. And if everything worked the way it should be, A prime is also 2.5 or 2.5 inches away from C. All right, so simple enough. And that's exactly what a rotation should do. A rotation should keep the pre-image point and the image pointer should keep the image point the same distance away from the center as the pre-image point. If not, then we're not doing the rotation correctly. All right, let's keep moving on. See what we've got next. All right, now, rotating points are one thing, but rotating an entire figure is something entirely different. So, in the next exercise, we're going to investigate an amazingly important property of rotations. So let's take a look at exercise number 2. We would like to investigate rotating segment AB by 120 degrees about point C in the counterclockwise direction to produce segment A prime B prime. Letter A asks us to rotate both endpoints, A and B. You will need to draw 2 arcs centered at C. All right, well, let's do the first one together, then have you do the second one on your own. And again, this is going to take a little bit. But what I want to do is I want to rotate point A by 120 degrees about point C. And again, this is going to be a little more challenging. The first thing that I'm going to do is I'm going to take my compass out. All right, and again, should be hopefully a little bit easier for you than me. I'm going to extend my compass so that it passes through point A. I want to try to do this as accurately as possible. Again, not so easy for me, but hopefully it's going to work out pretty well for you. I'm going to draw that arc, and somewhere the image point A prime's got to lie along there. I'm going to move this thing kind of out. Now I'm going to bring this up. I'm going to draw a ray through point A. Again, this is really just to help me with my compass. Okay, I want a 120 degree angle. So now I've got to find my compass. There it is. Bring this up, bring this back up, maybe move this out of the way. I got to do a lot of different things. Bring this down onto point C. Almost have it. I'm looking for a 120 degree rotation. That is going to be at right about here. So now I'm going to move my compass away. Yet again, bring in my straight edge. All right, that is a 120 degree angle right in here. You don't have to write that angle in. Just wanted to illustrate it for you. And there's my A prime. So again, let's talk about this really quick, right? I took my center point, which is the center of my circle, used it to set my radius out there at my pre-image point A, drew out an arc like this, and then I simply drew in a 120-degree angle where one ray goes through C and A, and the other one goes through C and A prime. And there's that image point. All right, this is kind of a mess, and I'm gonna have to do it again in a second on letter B. But what I'd like you to do is pause the video now and try to rotate letter B, or point B, by 120 degrees counterclockwise about point C. Go ahead. I mean, it literally looks like I got my piece of paper and I just threw my geometry tools on it. Let's do it. All right, so first thing I'm gonna do is bring my compass down like this. Again, I gotta draw that arc. So I've gotta set my radius first. Almost perfect. A little bit further maybe, and a little bit wider. I don't have the greatest control over this, but there we are. I love the fact that it suddenly turned blue. I don't know why that happened, but I'm okay with it. Hopefully you're all okay with it. All right, we're gonna put this over here. Now I gotta get that angle going on, figure out that 120-degree angle, which is more challenging than you might think. All right, I gotta get myself a ray through CB. Let me do this. Bring in my compass, get rid of my ruler for right now, and bring this thing over here, almost there, come on. There we go, 120 degrees, right about here, come on, right about there. I just need really something to give myself a second point with which to draw that 120-degree angle. There it is. Not bad. Again, the idea would be that this angle now would be 120 degrees. This will be point B prime. I apologize that it goes up into the writing, but I'm sure you can all handle that. And now what I'd like to do is I'd actually like to draw on the line segment. So after all of this is said and done, I finally actually produce my line segment. All right, wait until we rotate a triangle in just a couple minutes. All right, so there it is, right? There's AB and there's A prime, B prime. Okay, now what is this amazingly important property? Well, we're going to get down to that in our very messy letter B. Let's take a look. Measure the length in inches of the pre-image AB and its image after the rotation A prime, B prime. All right, so all I want to know, right, is the length of AB and the length of A prime, B prime. Pause the video now and figure those out in terms of inches. All right, well, let's take a look really quick. No big deal, bring my ruler over here. Again, depending on how your sheet has been photocopied, hopefully it's gonna be close. Looks like at least on AB, we are at 2 inches long. Awesome. And then if I measure out the length of A prime, B prime, now I get to see how accurate my construction was. Looks like it is also 2 inches long. The last piece of this, did the rotation preserve the length of the line segment? So let's take a look at that wording. Did the rotation preserve the length of the line segment? It's like preserving something in your refrigerator, right? It means it doesn't go bad, it doesn't change. The answer is yes. Okay, preserving means it doesn't change it. And the answer is absolutely yes. Okay, very important. Rotations are rigid motions. They do not change the length of line segments when they're rotated. And that's absolutely critical. It also isn't absolutely obvious. I mean, if you took an object and you just kind of rotated it, it would be pretty obvious that, okay, well, things aren't changing, right, in terms of their lengths. But here is a really kind of solid example where we kind of go through all of the rotation of the 2 points, we get the line segment, and it's exactly the same length as the original. All right, very, very important. All right. Now, the last thing and the hardest thing that we can possibly do with rotations is to rotate an entire figure. All right, because every time, right, we've got to do this, draw in the arc, measure the angles, etc., etc. Let's do that once in exercise number 3. Exercise number 3, we want to rotate right triangle ABC below by 90 degrees clockwise about point M. Letter A, do the rotation by drawing 3 arcs centered at M to produce triangle A', B', C'. Okay, yet again, why don't we do one of them together, then we'll have you do the other 2 by yourself, and then you can draw in the right triangle, etc. Try to be as accurate as possible when you're doing these, as I will as well, because like little issues here and there, and you're gonna get an image triangle that looks a little bit funny compared to the original. But let's do it. Let's rotate point M, or sorry, point A. We're not gonna rotate point M given that it is it's the actual image point itself. All right, or sorry, the center point itself. Just like before, I'm gonna, get my compass out, the length of that. All right, now I'm going clockwise this time, not counterclockwise, clockwise. And I'm gonna go a nice angle of rotation, which is gonna be 90 degrees. I'm gonna just set this over here, bring this out for a second. Maybe I'll go like this. And I want this ray to pass through M and extend past point A. Right now I need that 90-degree angle, so I'll bring my, bring my protractor in. Gotta love a 90-degree angle. All right, right about there. All right, I'm gonna bring this thing, throw it off, maybe just make it smaller. That'll work. Gotta love geometric things like rulers and whatnot that you can just make smaller and larger. And it should be right there. Whoops. Shift it a little bit. Right there should be A'. Okay, nice 90-degree rotation. And keep in mind, 90 degrees clockwise about point M. What I'd like you to now do is do the same for points B and C. It's going to take you a little while. Once you've got B' and C', connect them all with straight line segments to create the image of triangle ABC. Go ahead and do that now. All right, here we go, right? Now we're going to do point B. All right, so let's bring this thing out. Let's get an arc for point B. Almost there. A little bit farther. Okay, that looks good. Here comes my arc. I love the fact that my arc started as black, then it went up to blue. One of these days I'll really understand how to use this board. Gonna bring this in. Gotta construct that 90-degree angle now. Again, I just want my ray here going through M and B. All right. Bring in my compass. Maybe get it a little bit longer. Oh, that was right on the money there, though. Let's see. Really want it right about there, actually. I can mark it right like that because I've got a big compass. Let me get rid of this. Come on. I really should draw the other ray, but I'm gonna just try to take a little bit of a side step there. So there's my B'. Let me do one more. Let's do C'. Oh, almost. Yeah, that looks good. Here's that arc. Close that up. I really hope that arc didn't shift at all. be very difficult. Come on. Be nice to me, ruler. I bet sometimes your rulers just fly out of your hands, but all right. Now, let me get rid of this, like that. Now, if you're thinking there's got to be an easier way to do this, you're wrong. There's really no easier way to do rotations, unless you've got kind of geometric software that will allow you to do them. There we go, my 90 is right about there. All right, let me get rid of that, and here's letter C. Actually, that's letter C prime. There we go, letter C prime. Now, the only issue we have at this point is just connecting them all with line segments. Let me do that relatively accurately. Normally, I would just freehand something like this, but I really want to kind of do it here a little more accurately. So I've got that nice triangle sitting there. Here. Here. And here. All right. And there's triangle A prime, B prime, C prime, right? It may not exactly look like what you'd think it would when you rotate it 90 degrees clockwise about point M, but it is. Now, let's take a look at part B. Part B says, using tracing paper, determine if the two triangles are congruent, right? Are they identical? All right. Now, what you should be doing is you should be taking tracing paper, trace over this triangle, and then see if that image will lie directly on top of that one. Take a moment to try that. All right, great. Well, I've already, kind of done the tracing itself. Maybe unwisely, I did it in blue, but that is just the way it is. Now notice, it's hard. I can't really put it like that. But if I now rotate this thing almost, what I will find is that yes, yeah, right? Completely and utterly congruent, all right? And it's kind of neat, right? This idea that if I rotate all the points on this right triangle, right, by 90 degrees or by whatever angle, it doesn't have to be 90 degrees, don't get wrapped up in that, then the triangle that gets produced is congruent to the original, right? And therefore, going back to that idea, rotations are another example of a rigid motion. Rotations do not change the way a figure looks or its size, all right? A rotation is another example of a rigid motion. It creates an image that is congruent to the pre-image. So let's take a look at one last exercise. Exercise number 4. Trapezoid E prime, F prime, G prime, H prime is the image of trapezoid EFGH after a counterclockwise rotation about point A. All right, letter A, using your protractor, determine the angle of rotation. Show or explain how you found your answer. All right, well, we haven't done this yet, and yet I think you have enough knowledge to figure it out. So I'd like you to pause the video and see if using your protractor, you can figure out the exact angle of rotation. Go ahead now and try this. All right, well, here's the key. We simply have to measure an angle, right, that connects the center point to a point and its image point. So you could choose letter A and E prime, or H and H prime, or F and F prime, it doesn't matter. I'm going to choose E and E prime, that seems easy enough. And what I'm going to do is I am literally going to draw in this ray from A to E prime, or sorry, from A to E. And then I'm going to draw this ray in from A to E prime. all right, that angle is going to be my angle of rotation. Right? That must have been the angle that I rotated. Whoops. That must be the angle that I rotated E. Right? Now, I may not have it lined up the best right now, but that angle should be exactly 80 degrees. All right? And again, it doesn't matter whether I pick AE prime or AH prime, it wouldn't make any difference. We rotated E 80 degrees, I almost said 180, 80 degrees to go from here to here, and therefore all points were rotated 80 degrees. You don't get to rotate some points 80 and other points 60 and other points 30. Then it wouldn't be a rigid body motion anymore. All right? Now let me kind of minimize these so that we can look at the last part of this problem. All right. Letter B, circle each pair of line segments if the two must have the same length. Must have the same length. All right. So what I'd like you to do is like you to look at these four choices. There's more than one correct answer. I want you to find as many correct as you can and tell me, okay, are these two the same length? If so, circle them. If you can't say that they're the same length, don't circle them. Pause the video now and figure out which pairs have the same length. All right, well, I'm going to just erase this really quick. EH and E prime H prime, right? That's number one. Absolutely, right? Because E prime H prime is just the image of EH after the rotation, and since rotations don't change lengths, these two are the same length. Now, how about AE, right, which is the distance from here to here, and AH, the distance from here to here? Well, the distance from A to H and the distance from A to E could be the same, but they certainly don't have to be, and they don't really look like they are in this particular picture. All right, so those two don't have to be the same. All right, let's take a look at number 3, AF and AF prime. So the question is from here out to here, and from here out to here. And the answer is yeah, those things have to be, right? Because the whole point is if I were actually rotating point F over to F prime, we would be drawing this circle, right? With a center at A that would extend out to F and then would sweep into F prime. So the answer is yeah, those are definitely the same length. And finally, the length of EF, right, which is this length, and the length of HG, which is this length. Absolutely not. In fact, I don't know about you, but it looks like HG is considerably longer than EF, and really those are just two lengths of the original figure, right? And there's nothing that says those two lengths have to be the same. So 2 and 4 are out, but 1 and 3, those must have the same lengths. All right, let's wrap this up. So today we literally looked at the definition of what a rotation is, and that is simply basically moving a point along the sort of circumference of a circle, right? A certain angle measurement, right? A certain angle measurement. And that's it. Now, in order to do a rotation, we've got to know what is that center of rotation. You know, what angle are we rotating through? 60, 90, 120, 180, right? And whether we're rotating clockwise or counterclockwise. These are all important things to know. What we discovered today was that rotations, just like reflections, are another example of a rigid motion. In other words, if I take a figure and I rotate it about some center point, then the image that I get will be congruent to the original figure. It'll be the same size and it'll be the same shape. All right, I'd like to thank you for joining me for another NGen Math 8 lesson by eMathInstruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.